On the next couple slides, we're going to learn how to write conversion factors. I suggest you keep your common SI prefixes handout by your side while we do this. A conversion factor is something that is a ratio between two quantities that are expressed with different units of measurement. We can use them to convert between different prefixed units to base units or base units to prefixed units. We can also eventually go from one prefixed unit to another prefixed unit. So for an example, we want to write a conversion factor between grams, that will be our base unit because there's no prefix in front of it, and milligrams. We know it's milligrams because it has the lowercase m out front. Looking at our chart, there's two different ways that we could write this. We could say that 1 gram is equal to 1,000 milligrams, or we could also say that 1 milligram is equal to 1 times 10 to the negative third grams, or 0.001 grams. Either of these would be appropriate conversion factors. Both of them can also be written as a fraction for when we do dimensional analysis and actually convert units. We could say 1 gram over 1,000 milligrams, or we could flip that fraction upside down and say 1,000 milligrams over 1 gram. We can do the same thing for our other conversion that we wrote. 1 milligram over 1 times 10 to the negative third grams, or we can write that upside down. 1 times 10 to the negative third grams in the numerator over 1 milligram. All four of those fractions that we just wrote is equal to the same conversion factor. It's just four different ways of writing it. When we actually are converting units, we'll have to decide whether we need grams in the numerator or grams in the denominator, and that will depend upon what we're starting with and where we're going to. Let's try another example. Write a conversion factor between meters and nanometers. So first, it's important to think about what are the unit symbols that are associated with both of these. We know meter is going to be a measurement of length, and the base unit for meters is just lowercase m. Nanometers is going to be one of our prefixed units. Nano means that there's a lowercase n out front, and the symbol for meters is still just lowercase m. So nm will be our unit for nanometers. Reading our prefix chart, there's two different conversion factors that we could write, and they're both equivalent. We could say that 1 meter is equal to 1 times 10 to the 9th nanometers. So there's a lot of small nanometers in 1 meter. Or if we read the numbers right off of the prefix chart the way they're written, we can say that 1 nanometer, which is smaller than a meter, is equal to 1 times 10 to the negative 9th meters. Both of those conversion factors are equivalent, and we could turn any of those conversion factors into a fraction if need be. Let's try the second one. Write the conversion factor between grams and kilograms. In this example, grams is a unit of mass, and the symbol for grams is lowercase g. That's a base unit. There's no prefix associated with that. Kilograms is going to be a prefix unit. Kilo has the symbol lowercase k, and then grams is the symbol g. So kg will be the symbol for kilograms. We can write two conversion factors. First, we could say 1 gram is equal to 1 times 10 to the negative third kilograms. So there's going to be a small amount of kilograms in 1 gram because kilograms is the larger unit in this case. Or we can flip this around and say 1 kilogram is equal to 1,000, which is 1 times 10 to the positive third grams. In this scenario, we're asking ourselves, what's the bigger unit? It's the kilogram, and there's going to be 1,000 smaller units, which is the gram, in that 1 kilogram. I often find it easier to assign the larger unit as 1 and ask myself how many of the smaller units are in the larger unit. So the conversion factors I would write personally for the first example would have been 1 meter equals 1 times 10 to the positive 9th nanometers. And for the second example, the conversion factor I would have written would have been 1 kilogram equals 1,000 grams. I think it's easier to think about it in terms of the larger unit being assigned 1. And then you always have a positive exponent for how many smaller units are in a larger unit. Let's try another one and practice reading the prefix chart. How many grams are present in 1 megagram? So here you have capital M, lowercase g. Capital M stands for the prefix mega. So if we're saying we have 1 megagram, which is a large unit, how many grams, which is the smaller unit, are going to be present in that 1 megagram? So the factor there is a billion, or 1 times 10 to the positive 6th grams will be present in 1 megagram. Now we could turn this backwards. How many megagrams are present in 1 gram? So the megagram is still the larger unit and the gram is still the smaller unit. So this is going to flip. If we have only 1 gram, which is pretty small, how many megagrams is that going to be equal to? 1 times 10 to the negative 6th megagrams are present in 1 gram. This is actually the number you would see right on your prefix chart, but you have to understand how to read it. Next, we're going to combine writing a conversion factor with actually converting a base unit to a prefixed unit. So let's try an example. Convert 2 meters into kilometers or kilometers. So before we actually worry about doing any conversions, the first thing we want to do is write that conversion factor. And remember, there's 2 appropriate conversion factors you could write. So you have to decide how you're going to do that. I would say the kilometer is the larger unit, so I'm going to assign that 1. 1 kilometer is equal to how many meters? Well, the meaning is 1 times 10 to the positive 3rd, which is 1,000. So there's going to be 1,000 meters in 1 kilometer. Next, we want to set up something called dimensional analysis. That means we want to start with the unit and the number that we're given, which is 2 meters. We're going to set that up by writing 2 meters, and then we're going to use our unit conversion as a fraction. Before we actually plug in any numbers, think about where your units are going to have to go and where you want to end up. We want to go from meters into kilometers. So unit-wise, meters have to go in the denominator of our fraction, so they end up canceling, and kilometers have to go in the numerator of our fraction. What you're left with in terms of units in the upper right-hand corner of your fraction is going to be what your final answer is in. So now we just need to plug in the numbers from our unit conversion that we wrote. So 1 kilometer is equal to 1,000 meters. Notice the units meters are going to cancel because they're on the top and the bottom, and we're going to be in kilometers, which is what we were after. So we're going to take 2 and we're going to divide by 1,000. Our final answer should be 2 times 10 to the negative 3rd kilometers, km. Notice we included the number and we included the unit. Next, we're going to convert 30 grams into micrograms. So what are the symbols that we're going to need for those units? Grams is lowercase g, and micrograms is the Greek letter mu and then a lowercase g for grams. So first, let's write a unit conversion between grams and micrograms. I like to call the larger unit 1. So 1 gram is equal to, how many really, really small micrograms are there in 1 gram? 1 times 10 to the positive 6th, or a million micrograms are in 1 gram. Now we're going to set up our dimensional analysis. We want to do what we did last time. We want to start with the number and the unit that we were given in the problem, which is 30 grams. So 30 grams times, as a fraction, our unit conversion. So where are we going to have to put our grams? We know that that's going to have to cancel eventually. So our grams are going to go in the denominator, and our micrograms are going to go in the numerator because that's the unit we're trying to work towards. 1 gram is 1 times 10 to the positive 6th micrograms. We want to check. Our grams are in the denominator and they're in the numerator, so they cancel there. And the units that we're going to be left with are what's in the upper right corner, which is micrograms. That's good, that's what we're after. So when we multiply 30 times 1 times 10 to the 6th, we'll end up with 3 times 10 to the positive 7th micrograms. Once again, we're including the number and we're including the unit in our final answer. Let's try another example, but this time we're going to start with a prefixed unit and we're going to work backwards to a base unit. So in the first example, it says how many nanoseconds. The symbol for nanoseconds is going to be N for nano and then S for seconds, is 6.35 times 10 to the negative 8th seconds. The symbol for seconds would just be lowercase s. So we want to first write a conversion factor between nanoseconds and seconds. So we could write one of two conversion factors. I tend to say, what is the larger unit? In this case, it's the base unit of seconds, and I call that 1. 1 second is equal to how many nanoseconds? Nanoseconds are really small, so there's going to be a lot of them in 1 second. And the answer is 1 times 10 to the positive 9th nanoseconds are in 1 second. If we had read it directly off the prefix chart, we would have said 1 nanosecond is equal to 1 times 10 to the negative 9th seconds. So there's going to be a really small amount of seconds in 1 nanosecond. I tend to use the top one because it's a little bit easier to process. So now that we have our conversion factor, we can set up our factor label. We're going to start with what we're given in the problem in terms of the unit and the number. We're going to start with 6.35 times 10 to the negative 8th seconds. We want to write our unit conversion as a fraction, and we're going to put seconds in the denominator and nanoseconds in the numerator so our units work out correctly. 1 second is 1 times 10 to the 9th nanoseconds. When we look at our units, we can see seconds are going to cancel, and we're going to multiply 6.35 times 10 to the negative 8th by 1 times 10 to the positive 9th. We're going to end up with 6.35 times 10 to the first power, or simply 63.5 nanoseconds. Being sure to include your number and your unit in your final answer. Let's try the second one. How many grams is 2.35 kilograms? So grams is a base unit. It's going to have the symbol G. Kilograms is going to have the symbol kg. We want to write a conversion factor between grams and kilograms. There's two that you could write. I know that kilogram is bigger, so I like to call that 1. 1 kilogram is equal to 1,000, or 1 times 10 to the third, grams. The other conversion factor you might write is 1 gram is equal to how many kilograms? 1 times 10 to the negative third kilograms are in 1 gram. I have a tendency to use the top conversion that we wrote. So let's start with what we're given when we set up our dimensional analysis, sometimes called factor label, 2.35 kilograms. Now let's write our unit conversion as a fraction, times, we want kilograms to be on the bottom and grams to be on the top so our units cancel properly. We know that 1 kilogram is equal to 1 times 10 to the third, or 1,000 grams. From here, we can check. Kilograms is on the top here, it's on the bottom here. They will cancel, and our units will be left in, or what's in the upper right corner here, which is grams. So we're going to multiply 2.35 times 1,000. So our final answer for the problem will be 2,350 grams, including the number and the unit. Now we are going to take this one step further and learn how to convert a prefixed unit into another prefixed unit, whereas before we were going from a base unit to a prefix or a prefix unit to a base. We're going to have to map out a plan of how we want to do this. So let's look at an example. Your brain processes speech in 0.068 microseconds. How many milliseconds is that? So we want to go from microseconds into milliseconds. In order to do that, we're going to have to start with microseconds, which is what we're given, and actually go to seconds, which is our base unit, as a middle ground, then convert seconds into milliseconds. Now there are other ways to go about converting one prefixed unit into another, but this is a way so you can understand it and get the right answer every time without counting and guessing. That means we're going to actually need to write two different unit conversions. The first unit conversion will take us from microseconds to seconds. The second unit conversion we write will take us from seconds into milliseconds. So what are going to be our two unit conversions? The first one, what's our relationship between microseconds and seconds? Seconds is the larger unit, so 1 second is equal to 1 times 10 to the 6th, or a million, microseconds. Now for our second unit conversion that we'll need, that's going to be the relationship between seconds and milliseconds. Second is still the larger unit, so 1 second is equal to 1 times 10 to the third, or 1,000 milliseconds. So there's a lot of the smaller unit in the one bigger unit. Remember, both of those unit conversions we can use as fractions. Now we need to set up our dimensional analysis. We're going to start with what the problem gives us, which is the unit in microseconds. So 0.068 microseconds. And what are we going to want to do? We're going to first want to go from microseconds to seconds. So in the denominator, we're going to put microseconds. In the numerator, we're going to put seconds. We just wrote a conversion between those two. We know that 1 second is equivalent to 1 times 10 to the positive 6th microseconds. If we stop now, our units would be in seconds. The microseconds would cancel. But we want to take this one step further. So we're going to write our second unit conversion as a fraction. And this time we're going to put seconds in the denominator so they cancel. And we're going to put milliseconds in the numerator. That's what we're trying to get our units into. 1 second is equivalent to 1 times 10 to the third milliseconds. Seconds are going to cancel, and we're going to be left with milliseconds. So in order to put this into your calculator correctly, what you need to do is you need to type 0.068 times 1 times 10 to the third, and then divide by 1 times 10 to the 6th after. So you multiply everything on the top of all the fractions, and then you divide by everything on the bottom. The answer you should get is 6.8 times 10 to the negative fifth milliseconds. Let's try another example. How many micrograms are in 65.3 kilograms? So whether you're given the words or you're given the symbols, you need to know what they mean and how to convert between them. So micrograms would be symbolized with mu and then a lowercase g. That's a unit that's smaller than the base of just grams, whereas kilograms or kg is larger than the base unit of grams. So our plan of attack here has to be, we're starting with kilograms, that's what we're given. We're going to go to the base unit grams, and then from there we're going to convert to another prefixed unit of micrograms. So just like last time, we're going to not have one unit conversion, but we're going to have 2 unit conversions that we have to write. So for the first one, what's the relationship between kilograms and grams? 1 kilogram is equal to 1,000 grams. And then the second unit conversion we're going to need to write is the relationship between grams and micrograms. 1 gram, which is the larger unit, is equal to 1 times 10 to the 6th micrograms. So there's 1,000,000 micrograms in 1 gram. Next, we're going to start setting up our dimensional analysis. We're going to start with that 65.3 kilograms we were given in the problem. 65.3 kilograms. And we're going to use our first unit conversion as a fraction. We're going to want to put kilograms in the denominator so they can cancel. And we're going to want to put grams in the numerator. Now we plug in what we wrote from our unit conversion. 1 kilogram is 1,000 grams. If we stop here, we can see the kilograms will cancel and we'll be left in grams. But we're going to take it to the next step. Now we're going to put grams in the denominator and we're going to put micrograms in the numerator. We said that 1 gram is equal to 1 times 10 to the positive 6th, or 1,000,000 micrograms. Now our grams will cancel, and the final units that will be in are what's left in that upper right-hand corner, which is micrograms. So if we multiply 65.3 times 1,000 times 1,000,000, we'll get our final answer, which is 6.53 times 10 to the positive 10th micrograms. Making sure to include our numerical answer as well as the units. So this is going to be the last example that we do together using our prefix chart. You should work on the homework problems from the book and the homework problems online, as well as their extra practice problems that are on Blackboard, as well as a key, until you can do this with ease. So let's try this last one together. A dose of medication was prescribed to be 35 microliters. So liter is a unit for volume. It's a derived SI unit. And microliters would mean the symbol for this is the micro with capital L. What is the volume in centiliters? So centi, the symbol is lowercase c, and then liter is still going to be capital L. So those are the symbols for our units that we're going to be using here. So our plan or our pathway that we're going to want to take is going to be microliters, and then to our base unit of liters, and then to our new prefix unit, centiliters. We're going to write 2 different unit conversions for each of those. So a unit conversion between microliters and liters, that first unit conversion. 1 liter is going to be equal to 1 times 10 to the 6th microliters. And our second unit conversion is going to be between liters and centiliters. 1 liter is equal to 100 centiliters. Now that we have our unit conversions, we can start with what we're given in the problem, which is 35 microliters. 35 microliters, and we're going to want to convert microliters into liters. 1 liter is equivalent to 1 times 10 to the 6th microliters. Microliters would cancel. We'd be left in liters at this point. Next, we'll use our second unit conversion, this time putting liters in the denominator and centiliters in the numerator. There's 100 centiliters in 1 liter. Liters are going to cancel because they're in the numerator and the denominator, and our answer will be in centiliters. And our final answer here, when we multiply 35 times 100 and then divide by 1 times 10 to the 6th, is 3.5 times 10 to the negative 3rd centiliters. So you really need to practice with that prefix chart and understanding how to read it and understanding how you feel most comfortable writing those unit conversions so you can write them and use them. It might be helpful to make flashcards in the beginning so you can remember what prefixes are larger than the base units and what prefixes are smaller than the base unit. Then you can properly ask yourself, how many smaller units are in one of the larger units, if that's what you also would like to do.